Hi class, welcome to lesson 25 of atomic structure. Here we are going to examine Lewis dot diagrams and how they are used to represent both atoms and ions. Not only are we going to define a Lewis dot diagram, but you are going to be able to draw those for atoms and ions by the end of this video. Lewis electron dot structures are very useful in chemistry because they just show valence electrons. As we can recall, valence electrons are the electrons in the outermost principal energy level. Those are the electrons furthest from the nucleus. Only these outermost electrons are going to participate in bonding. We can recall from earlier in the year that when two nonmetals bond, they'll form a covalent bond and share electrons. When metals and nonmetals bond, they will form an ionic bond where metals form cations that lose electrons and nonmetals form anions that gain electrons. This transfer of electrons is synonymous with an ionic bond. So we know that valence electrons are those electrons that participate in bonding. This is done so that atoms can obtain the most stable electron configuration, which happens to be the same as the noble gas or group 18 electron configuration. There are many methods to drawing Lewis dot structures, and many textbooks might not agree with my technique, but I promise you, if you use this technique, you will first get all of the questions right on the Regents. Second, you'll only have to have one technique for every application of drawing Lewis electron dot structures that we'll see again in bonding and in organic chemistry. So although this might not be the same technique that all textbooks use, many years of experience have taught me that this is 100% acceptable and will always be accepted on our Regents, and I believe it is the simplest technique. When drawing Lewis electron dot structures, you must begin with your element symbol in the middle. From there, you have to imagine that there is an invisible box around your element symbol. Your dots must appear on the perimeter of this box. That means the dots above and below the element symbol will be horizontal, while the dots to the left and right of the element symbol will be vertical. If you think of this box as having a north, east, south, and west side, you have to pick one of these sides to start on. Once you pick a start, you begin dotting in a circular fashion, and you place one dot per each side of the box in a circular pattern until you accommodate all the necessary electron dots. So neon, which has a complete valence shell of 8, you'll dot them in this exact order. 1, 2, 3, 4. Notice we have no pairs of dots when we have 4 or fewer electrons in our Lewis dot structure. 5, 6, 7, 8. Now, valence electron dots are really important because we know that if any dots do not appear in a pair, then those are going to be places where bonds will form. Let's practice a couple Lewis dot structures to make sure that you have the general idea. The first thing you'll want to do is use your periodic table to find the valence electron number for each species. Here, we're going to begin with potassium. Recall that the valence electron is the furthest from the nucleus. So when we look at potassium, we can see that potassium has a valence of 1. So when we draw the Lewis dot structure for potassium, potassium will simply have one dot. It doesn't matter which directional coordinate you choose. So although the above structure is correct, we could have that dot anywhere relative to our potassium symbol, and it would be 100% acceptable. Now let's move on to nitrogen. Nitrogen has a valence of 5. So again, it doesn't matter where you start. In this, for this atom, I like to start on the north. So we'll dot one dot at a time until we get to 5. 1, 2, 3, 4, 5. So here we have 5 electrons. We have 1 pair of electrons and 3 unpaired electrons. That means nitrogen makes 3 bonds. Fluorine has a valence of 7. Again, I like to start my valence on the north for fluorine, but I could start anywhere, as long as I have 7 dots. Going in a circular pattern until I've finished 7 dots will look something like this. 1, 2, 3, 4, 5, 6, 7. Notice that fluorine has 3 pairs of electrons and 1 unpaired electron. That means fluorine typically makes 1 bond. Recall that the magic number in chemistry is 8. 8 valence electrons are the most common number for noble gases, though sometimes smaller atoms might want 2 valence electrons. Hydrogen only has 1 valence electron, or 1 electron altogether, so it has a very simple Lewis dot structure, just 1 dot. Barium has a very large electron configuration, but we're only going to focus on the valence electron, since only those electrons participate in bonding. When I draw barium, if I start on the east side of my symbol, I have 2 dots. Now remember that I'd mentioned earlier that there are other techniques for drawing Lewis electron dot structures. Sometimes the Regents uses that technique, but what they'll never do is they'll never go and have the wrong number of dots. Some people draw the Lewis dot structure of barium with its first 2 electrons paired. This is not the technique that I advise, but of course, since the Regents accepts it, so will I. When working with ions, it is important that before you draw the Lewis dot structure, you must adjust the valence electron configuration to the correct number of dots before making your final diagram. Ion diagrams, you'll see, always have their Lewis dot structures in brackets with the charge outside. It is always true that negative ions should have complete valence shells with 8 electrons, and cations or positive ions should have empty valences as they will have lost electrons. Let's do a couple ions together. So here are the atoms that we went and looked at before. Now that we're going to go and examine their ion structure, the first thing you'll want to do is look up the ion charge on your reference table. After looking up the ion charge, it is best to put your symbol in square brackets so that you don't forget later. The last step you'll have to do is to adjust the electron configuration to represent the ion charge. So remember that ions get their charges because of an unequal number of protons and electrons. Using my periodic table, I've written down the atomic number, which is the same as the proton number for each species. I've also written down the total charge. Recall that charge should be the number of protons minus the number of electrons. So that means when I have a positive 1 charge, I must have 1 less electron. This means I should only have 18 electrons. To make 18 electrons, we're going to remove potassium's 1 valence electron from the atom. That means we'll have 0 dots. Next, let's look at nitrogen. If nitrogen has a charge of -3, it must have gained negative electrons. That means that there should be 10 electrons. Since currently nitrogen only has 7 electrons, to get 10 electrons, we'll have to add 3 electrons to its valence shell. That means nitrogen will have 8 dots. Remember, we'll add dots one at a time in a circular fashion until all valence electrons have been accounted for. Fluorine has a -1 charge. That means it has gained 1 electron. If fluorine were to have 10 electrons, it needs 1 more in its valence shell. So fluorine's valence is 8. When hydrogen has a +1 charge, it has 0 electrons. So we have to remove its only electron. Hydrogen has no dots. Finally, barium. If barium were to have a +2 charge, it should have 2 more positives than negatives. That means it should have only 54 electrons. That means we're going to remove the valence electrons. So again, we can see the trend is positive ions have no electrons. While negative ions tend to have 8 valence electrons. Now it is time for you to test your knowledge of chemistry and Lewis dot diagrams by answering these questions. You will find some helpful hints on the video. Make sure if you have questions, you bring them to class. See you soon.